Hey Don, Mr. Sipple here. Just want to go through with you the uh, Unit 1 practice test for geometry. So a couple things with going through here is that you don't need to watch necessarily every question, right? So if you only had questions with a few of them, then you fast forward to the questions that you need a little review on. If you're completely lost, then I think you stick with us through this whole video. And then the idea here is that after watching this or while watching this, that you take the second part of the practice test, so that hopefully after reviewing it, then you feel a little bit better and able to take the test. I just want to point out one thing with CUDA before we begin, is that if you want to skip a question or go back to a question, at the top right here, if you click the three dots, it'll say Show Question Progress. And then when you do that, at the bottom here, now it has all the questions, and there's a total of 27 questions for this practice test. Why doesn't it do that automatically? I don't know, it should. But so you just have to turn that option on, and then what this allows you to do is jump around if you want to skip a question. If you've already answered a question, it doesn't let you go back. So that dark blue means I've already answered it, and I can't go back. So if you're not sure about a question, don't move forward. Don't submit your answer, rather, and then skip it, and then you can always come back to it. All right, first question. This is just making sure that you understand that what we're looking for is that you are, for the questions that require some scratch work, that you're doing that on some binder paper or another piece of paper, and then you will be submitting that work to Canvas, a picture of that work, at least the Canvas, so that we know for sure that that you actually did the work that you said you did. All right, so we got that one covered. Let's go ahead and move to the second question, which is the first real question here. So these next 5 questions are going to be referring to the diagram number 1 that's on the image sheet. So this question is saying what is the vertex of angle ZUT? All right, so vertex, first of all, a couple of things just to kind of point out is that what the vertex is, we think of the vertex as what we call the turning point. So if you have an angle, say I have an angle, and I'm not even worried about the letters just yet, but let's say I have an angle that looks like this. What we mean by turning point is that the angle comes in, it hits a point, and then it turns, and then it goes a different direction. So this point right here, that's what we refer to as the vertex. And then so when we use 3 letters to describe something, let's say, for instance, ZUT. So if I look at ZUT, and there's a lot going on with this diagram, so I'm just going to highlight the ZUT part of it. So we always follow it in the order that you see it, the letters. So the order does matter here, Z-U-T. So that means I'm going to start at Z, I'm going to go into U, and turn at the turning point, and then I'm going to go out towards T. So in this case, the vertex where I turned was at point U. So then U would be my vertex. It's always another little hint here too, is that when you see it written as angle ZUT, the middle letter is always the vertex. So the middle letter is always the vertex. So that's a way I could have got that without even looking at the diagram. I could have got that question correct because I could have just looked to see what the middle letter was, and the middle letter is always going to be my vertex. So just so we kind of understand that idea then real quick, let me just throw another example in here. Let's say I wanted to know, let me highlight another angle here real quick. So let's do this one. So then if I wanted to know what the name of that angle was, then I started at letter W, so that would be angle WZ, and then it turns at Z. So then Z would be my vertex. And then I would have WZB. That would be my vertex. So just look for the middle letter or where the angle turns, and that would be your correct answer there. All right, so go ahead and pause here and try number 2, or we will carry on to the next question. Number 3, so it says, what is another name for line H? So we have a couple different ways that we name lines. When we name lines, we use either, I'm just going to make a note here. So I'm going to say naming lines. So when we name lines, there's 2 ways we do it. One is with a lowercase letter. which is that's what they've done here is they named it H. So line H would be this line right here. I'm just going to go ahead and highlight that. So that's one way that we could name it. The other way that we name it is that we name it by the uppercase letters that are on the line. So the uppercase letters on the line. When we use a lowercase, it's usually a lowercase letter at the end. So you notice that H is at the end there. Or we could use the uppercase letters that are actually on the line. So a couple different ways we might name this is that we could do start, and I'm going to just kind of list out some possibilities here. So I could start at the very kind of going at the top to bottom here, so TV. So I could say TV. And then you notice I do a little line here to indicate that that means that it's a line. So we do, if it is a line that goes on forever in both directions, then we do use that symbol to represent that. If it has an endpoint, kind of a beginning and an end, right? If it looks something like that, then we just use a bar. I'm just going to do AB, for instance. I'm just using any letters here. And then if it has an endpoint, but then it goes on forever to the other way, then we use this symbol here. We use the endpoint and then an arrow. So the TV's got arrows on either end. So TV's a line. They also tell us that because it says line in the problem. And then so what we're going to use, we'll use either TV, or I could flip it around and I could use VT. So I could actually switch the order of those two things. So I could do VT. If I look at the multiple choice, I actually don't see TV or VT as one of the options. And that's because there's a couple other ways we could name this. So we could also use, I don't have to use the letters that are on the kind of the outer ends. I could also use a letter that's on the inside as well. So if I wanted to do that, then what that would look like is I could do Z, T, or I could do TZ. Now let's see if one of those is there, right? By the way, I could rule out this one right away because it doesn't have the arrows on either end. So it's a line, and that's saying that it's a segment. That's not true. ZS, look at ZS. ZS is going off in this other direction, so that's not even on the right thing. So I could rule that one out. TZ, that's what I'm thinking it is. And then let's look at UW. UW is the other line that's here, right? So then my correct answer would be that. Let's say that TZ wasn't there. Another option could have been using Z and then V, or flipping that around and doing VZ. Could have done that too. All right, so go ahead and pause here and try number 3, or otherwise we will move on to number 4. Number 4, using the same diagram here, it says, what is the segment bisector? Well, first of all, we need to understand what that term bisector means. So segment, we know that we're talking about something that has a beginning and an end, right? That's a segment. And then if we think about a bisector, that prefix bi means two, and sector means like sections. So what it means is to cut into 2 sections or to 2 parts. So we're cutting it in half, right? So in other words, that means to cut in half. 2 equal parts. And then we would indicate that our little symbol that we use for geometry to indicate 2 equal parts is that we just would use a little tick mark here. So I would say that that segment would be congruent to that segment, right? And then so what we're looking for is then what is the segment bisector of UW? So we're saying that UW, and let's kind of identify where UW is. So here's UW. And we're saying that UW got cut in half. Well, it's actually already marked here for you. If you notice, there's a tick mark there to show that those 2 are equal because they got cut in half. Now what we're looking for is what what was the thing that came down almost like a knife to cut it in half? Well, if I look at what cuts it in half, if I kind of go this other direction, then I see that it looks like this is what cut it in half. Now I just need to figure out what to name that thing. Well, I can go through the options here. It looks like that it would be T, and I'm just going to go from the one end to the other. So it looks like that would be TV. And I feel pretty good that that's the answer, but it's always good to just double check and make sure why the other ones were wrong. UT, well, UT is over here. That doesn't cut it in half. TS is over here. That doesn't cut that in half. UZ is part of that segment, but it's not what cut it in half, right? So what cut it in half was that segment TV. All right, so that's number 4. Pause here, or we'll move on to number 5. Number 5 says, which of these is a ray? So just like I don't know, with ray, I always think of a sun, right? You think about when you were a kid and you drew a sun on your paper, right? You probably drew something that looked like this. So the idea of a ray is that it has a starting point, and then it has an arrow that goes on forever in the other direction. So that's what we're looking for. We're looking for something that has a starting point, and then it goes on forever in that other direction. Well, let's kind of just run down the list here that they give us. US is actually, that's one segment, and then there's another segment. But you notice there's no arrow. Nothing goes on forever there. So that's not it. ZU, so you notice that ZU, Z has a starting point, but then U has an ending point. This doesn't go on forever after U. So that's not a ray. This is a segment, right? And that's what this one was too. This one was also a segment. What about ZV? Well, Z has an endpoint, or kind of a starting point rather, right? And then it goes on forever in this other direction. So that would be our answer there. Let's see. Let's double check though. Why is SZ not the correct answer? Well, the order matters here when you write array. You write the endpoint first, and then the part that goes on forever is the second letter. So this actually would have been correct had they written ZS and written it this way. That would have been correct. But they kind of got it backwards. They started with infinity and then went to the point. It goes the other way. You start with the point and then go out to infinity. So that's why that one would not have been the correct answer. All right, so that is number 5. Give that one a try, pause it, or otherwise we will go on to number 6. Using the same diagram, this is the last question using the same diagram. So it says, which congruency statement is true? So in geometry, our little shorthand notation for that something is equal is we use this symbol for congruency. It's an equal sign with a little tilde at the top. So this is our congruency, little kind of shorthand for congruency, right? Symbol, that's the word I was looking for. Well, I think probably the easiest thing to do is so we're basically trying to figure out what this is really asking. Is it saying which angles, or they also give us some segments are congruent. And when we say congruent, again, we just mean that they're equal to each other, that they're the same. Well, let's compare TZU. So I'm going to compare TZU. TZU is, let me get my highlighter here. So TZU is this angle, all right? And then VZW. So VZW, okay. Well, just by inspection, just by kind of looking at it, you might say like, yeah, those look equal. There's also something else that would indicate to us that those two things are equal. And that would be the fact that there is this arc here. So if you notice this arc, that's how we really determine that those two angles are equal. We don't eyeball it because maybe the diagram's off. But those two things do appear to be congruent by looking at it, but then we know for sure that it's congruent by the arcs. So I'm definitely thinking this is probably my answer, but again, it's always a good thing to go through there and rule out everything else. SZT, so SZT is this angle here, and UZT, so the one that's next to it. So we're saying these two angles here. Well, even though they look congruent, I can't say that this is congruent because there's no arc, right? So there's no little congruency arc there. So I cannot claim that those two things are congruent. If there was, I could, but there's not. ZS and ZU, so ZS and then ZU. Well, this is a segment and that's a line. So they're not going to be the same because ZU ends right here. ZS goes on forever this way. So I can't say that those two things are the same. STZ, so STZ, STZ. So STZ, notice it's coming at it. T is my vertex. So I'm going, I'll use a different highlighter here. So let's do STZ. So I'm actually looking at this angle right here. So STZ and then UTZ. So UTZ. Well, same thing. They look like they're the same, but there's no congruency mark there. There's no arc. So if without there being any sort of arc or degrees, I mean, if it said like 28 degrees and 28 degrees, but it doesn't. So then therefore I can't say that that one's correct either. So my first answer there would be A. All right. So again, pause here or number 7. Number 7 says find the length indicated. So what we're looking for here is that we have 2 parts and 2 parts make the whole, right? So this is, we call it our segment addition postulate. But the way to think of it is just that the part plus the part equals the whole thing. So what are my 2 parts here? Well, my part is question mark. I don't know what it is, so I'll just call that X. They use a question mark, but we'll use a letter. So I know that that part plus that part is equal to the whole thing. I was kind of thinking of these as like road trip problems. Like, we drove, we're driving from here down to Los Angeles. So we drove down the 101 for a while. We stopped, got some gas, got back in, drove a little further. The whole trip was this. So we want to know how much was the first part of the trip. Well, if it's a pretty simple equation here, and you could probably just figure it out even without using an equation. But so the answer would be 12, right? Because what plus 8 makes 20? Well, 12 plus 8 makes 20. So our correct answer there, would be 12. All right. So same thing, pause, or we'll move on to number 8. So number 8 is very similar to 7, except for we took, I guess, 2 pit stops on our road trip here. So now we have part plus part equals the whole. So same idea, and we could throw in other pit stops, right? We could throw in 4, 5. I mean, it doesn't matter, but it's just how many segments of the trip that's going to add up to the whole trip, right? So, and I don't know what this is here. They didn't use a question mark this time. I'll just write in X. So then I know that X plus the second part of the trip was 8, plus the third part of the trip was 6, and then the total trip was 18. So I'm just going to combine some like terms here. So I've got X plus 14 equals 18. And then when I solve for X, I get 4. Right. Now, what I'm going to do is that I need to plug back in. I didn't do that. Did I do that on the previous one? Find the indicated length. Oh, we were looking for that one. 7, 12, yeah. Sorry. Some of these, I had to catch myself there because some of these, they want you to just to find X and that's it. And then some of them, they want you to plug the number back in. So on this one, back when I was just double checking number 7, that was just find DE, segment DE, which was 12. Notice on this one, though, the answer, we're looking for find HI. Oh, okay. So, yeah, actually, that was the same thing on this one, too, then. I think in the next one, we'll have one where we have to plug it back in. But this one, yeah, was just 4. Okay. All right, so pause here, or we'll move on. Oh, okay, yeah. So number 9 here, this is what I was thinking of, where we got to plug it back in. So here's our 2 parts. The only difference here is that there's some variables in there, but the idea is still the same. Here's the first part of the trip. So the idea of part plus part equals the whole thing. That idea is still the same. So we've got x plus 17 plus x plus 13, right? First part, second part. And then that's going to equal the whole thing, which would be 18. And then I just need to combine some like terms here. So if I have an x and an x, that's 2x. If I combine 17 and 13, that gives me 30. And then now I just got a little 2-step equation I need to solve. So I get 2x equals negative 12, and then x would be equal to negative 6. Now, so you notice negative 6 is not one of the answer choices because that's not what we're looking for. We're not looking for what x is. They want to know what ED is. So ED would be this part of the trip right there. It's the second part of the trip. Well, so all we have to do is then just take negative 6, and then we're just going to plug that back in. So I'm going to take negative 6, and I'm going to go whoop, all the way over here. And then so ED is going to be, ED is x plus 13, but I'm going to plug in negative 6 for x. So I'd have negative 6 plus 13, which is going to be equal to 7. So ED would equal 7. All right, so same deal. Pause here, or we'll go ahead and move on to number 10. Okay, so same type of question as the last one. It's just we broke up our trip into 3 sections instead of 2 sections. But again, the same idea, part plus the part plus the part equals the whole thing, right? So I'm going to say x minus 5, that's the first part of the trip, plus 9, second part of the trip, plus the third part of the trip, 2x minus 19. And that's equal to the total distance, which would be x plus 9. It looks a little messy here at first. We've just got some like terms we need to combine. So we just got to kind of clean things up here a little bit. Let's combine all my numbers. So negative 5 plus 9, which would be 4, minus 19, which would be negative 15. Now, if you'd rather use a calculator for this, by the way, do that, right? So if you're not sure, if you're kind of still saying like, sometimes I forget my positives and negatives, that's okay. So I just would put this in a calculator then. So I'll do negative 5 plus 9 minus 19. I get negative 15. So this isn't mental math class. If you need to use a calculator, use a calculator. There's no shame in that. So I've got x plus 2x, and then minus 15. That's what I got from my calculator, equals x plus 9. I can combine these two, so 3x. And really what this is just a little review kind of from Algebra 1 of how to solve an equation. We're just doing it in the context of a geometry problem. But really at this point, it's just an algebra problem of how to solve an equation. Remember, when you have x's on 2 different sides, you got to get everybody over to the same side. So it doesn't matter if I move x over with the 3x or 3x over with the x. Some people like to move everything to the left, or smaller is bigger. Just personal preference, doesn't matter. And then we'll add 15 to both sides. So we get 2x is equal to 24. And then we'll divide by 2. So we get x equals 12, right? Now, so you'll notice that 12 is not one of the answers that's listed there. And that's because what we're looking for here is we're looking for FG. So FG is this section right here. It was the last part of our little trip. So then what I have to do is that I'm going to plug that in. I need to take x and I need to plug it in to see what I get here. So FG is equal to 2x minus 19. And then what I'm going to do is that I'm going to take what x is equal to, which is 12, and I'm going to plug it in right there. I always like to do parentheses when I do my substitution. So we'll plug it in a 12. And then so this would be 24 minus 19, which would be 5. So my final answer is FG is equal to 5. Right? All right, so kind of a two-step problem. We had to solve for X first and then plug it back in. Thankfully, on this one, they weren't too evil. Sometimes they're evil and they would have 12 as one of the options, and then you would see 12 and get all excited and circle it. So just make sure you're careful with that, because in this case, we weren't looking for just X. We had to find X then to figure out what that segment length was. All right, so pause here, or we will move on to number 11. Number 11 says points A, B, and C are collinear. So we got to figure out what that word collinear means. That prefix co is right, collinear. That prefix co means with, like a companion, right? Is someone that's with you. And then linear just means line. So these are points that are with the line, right? So another way that we can think of that is that the definition is that they're points that are all on the same line. So points all on the same line. Now this one's a little bit different because they didn't give us a diagram. All the other questions have given us a little picture to work with. That's okay. We just got to make our own little picture. So I'm just going to start with a line. And then it says there's points A, B, and C are on that line. Okay, so I'm just going to do an A, a B, and a C. I don't know that it doesn't say anything about B being, it says B is between A and C, but it doesn't say that it's the midpoint. It doesn't say that it's halfway in between. So I cannot make that assumption. And then, so BC is equal to 2, so we'll fill that in. So let's say this is 2. And then it says AB is equal to 7. And then it says find AC. Well, AC is just the whole thing here, right? AC is just this whole distance. Oh, a little too far. So AC is the whole distance. Well, so it's the same idea of part plus part equals the whole. So if part of the trip was 7, the other part of the trip was 2, that means the whole trip was 9. So that means that AC would be equal to 9. All right, so either pause here or we will move on to the next. And just real quick, there's a little typo there. It says 17 and 18. That should be 12 and 13. So we're going to, these next two questions are similar. All right, so types of angles. We have some names for some angles. And I'll just kind of list some of those out. Of course, if an angle is at looks like an L, like that, right? Then we call that a right angle. And then, but if you have an angle that is smaller than 90 degrees, so let's say you have something that looks like this, when you think something is cute, it's usually something small. So that would be an acute angle, which would be less than 90 degrees. Right angle is 90 degrees. This would be less than 90. And then if you have an angle that is greater than 90 degrees, we call that an obtuse angle. And then that would be between 90 and 180, right? So bigger than 90, but less than 180. So it's in between 90 and 180. And then if you have an angle that's just a straight line, well, if you think about a circle, right? A circle is 360 degrees all the way around. Well, half a circle is 180. So we call this a straight angle because it's a straight line. And then that would be exactly 180 degrees. All right, so now we're looking, so they say a straight angle. Well, I can already tell you right now which one it is, right? If I'm just looking at straight, the only one that's a straight line is that one right there, right? But let's rule out what the other ones are. What kind of angle is this? Just a little bit of practice. That's less than 90, so that would be acute. That is an L, so that's a right angle. And then that's greater than 90, so we would say that's obtuse. Just a little extra practice there to make sure we got the idea. But the one we were looking for was straight. The only one that's a straight line would be that one. All right, so the next one, now that maybe we'll kind of do these two together. So 13 then, since now that we kind of defined all of those things, well, I could say we're looking for acute, and acute means less than 90. It's a little baby angle. Well, that's right. That's not it. That's less than 90, so I'm thinking that's the answer, but let's just double check. That's greater than 90, so that would be obtuse, so that's not right. And then that's also right. So the only angle that is acute here would be that second choice. All right, so pause here, or we will move on to number 14. All right, so this one says EKJ is equal to 34. So remember, K is your vertex, the middle letter is your vertex. So EKJ, that means that this angle right there is equal to 34 degrees. And LKE is equal to 85 degrees. And then what it's asking is it's asking to find LKJ. Well, LKJ is that whole thing, right? LKJ. Oh, well, so this is still the same idea of part plus part equals whole. It's just instead of a part of a segment, now we're saying part of an angle. So part of an angle plus part of an angle is equal to the whole angle. Well, if this part is 34, this part is 85, let's just add those two things together. Let me use my calculator, just make sure I don't make a silly little mistake. So that would be 30, what do we say? We said 34 and 85. So 34 plus 85, and that equals 119. And there's 119 right there, right? Not really any work to show on this one because all we were doing, the work is probably labeling the diagram. I'd make sure I labeled the diagram. Don't try to do that without labeling it. But once you got it labeled, then you just see, oh, I've just got to add those two things together, and that gives me the whole angle, right? All right, so pause here, or we will go ahead and move on to number 15. All right, so same kind of question here. So it says so find LMQ. So we're looking for LMQ. So LMQ is that angle right there. So it looks like in this case, we're actually looking for the part. And then so what we have, maybe I'll just call this X. We don't know what that is. And then it says LMN is 174. Well, LMN is LMN. LMN is this whole thing. It's almost a straight angle. Straight angle is 180, right? So that's why it almost looks like it's half a circle. So this whole thing is 174. And then it says QMN. So QMN. So this would be equal to 150. So this other angle here is going to be this right here. That's going to be 150. Okay, so it's still the same idea. Part plus the part equals the whole. It's just the difference here is that now we know the whole, we just don't know the part. Well, I know that X plus 150, whatever X is, would equal 174. And then now I just need to solve for X. And then so when I do that, I get 24. And so 24 degrees would be my answer. So the difference here is that we knew the whole distance, the whole angle, we just didn't know the part. So we had to solve for the part. On the previous problems, we knew both the parts, just not the whole. So sometimes those things get flipped around like that. All right, so pause here. Or number 16. All right, so number 16, IJK, find measure of IJK. Okay, so IJK. Okay, so that makes so that's the whole thing. So it looks like we're going to be finding the measure of the whole thing. MJK is 118. So MJK, so this one right here, MJK is 118 MJK. So this is 118 degrees. And then it says IJK is 18x plus 2. Okay, well, that's the one we're actually looking for. So ijk is this whole distance, and they're saying that it's equal to 18x plus 2. And then it says ijm, which is this part right here, is 4x plus 10. So this ijm is this other little wedge over here. And so that would be 4x plus 10. Well, so here's your two parts. 4x plus 10 is a part, 118 is a part, and then it's equal to the whole, which is 18x plus 2. So we just need to set up an equation. This is where setting up the diagram is really important, because if we put the wrong number in the wrong spot, then we're going to get the wrong answer. So you've noticed me kind of like saying it out loud several times. I'm kind of reading it to myself, just making sure that I'm getting the right angle, because this is really a crucial part. All right, so the part is 4x plus 10 plus the other part, which is 118, equals the whole thing, which is 18x plus 2. Hopefully now this is the easy part, right? Like solving the equation hopefully is the easy part. The setting up of the equation can be the tricky part. All right, so we're going to add, let's combine some like terms here. So I'd have 4x plus 128. Now I've got x's on both sides. I need to get everybody together on the same side. Another preference, but sometimes people just move the smaller to the larger. So I'll move the 4x over with the 18. So I get 14x plus 2. I'm going to subtract 2 from both sides. 130 equals 14x. How many times does 14 go into 130? I don't know. Use calculator, right? That's what it's there for. So we'll do 130. So we'll do 130 divided by 14. And we get 9.28 something. Let's see. Were we supposed to get a decimal? I heard you yelling at me through the screen, I promise. Because a second ago, I heard you say, oh, wait, it's not supposed to be 130. It's supposed to be 126. So notice what happened here. This is a very good example. I just call these human being mistakes. It's not even really a math mistake. I mean, I wrote minus 2, but 128 minus 2 is not 130. What did I do? I added it for some reason. I have no idea why I did that. Right. So I think that's a good example of the kinds of mistakes sometimes that happen to us, is we just little silly stuff. So immediately what I did is that, I saw in my calculator, I knew I wasn't supposed to get a decimal. And then I started looking back, and then oh, okay, 128 minus 2, that should have been 1. So let's fix this. So that should have been 126. Right. So I'm actually glad that came up at least one time in this video. Because I see students make that kind of mistake all the time, and then they think like, oh, I just don't know what I'm doing. I'm not good at math. That doesn't have anything to do with not being good at math. It's just being human. We make mistakes. So the correct answer there should be x equals 9. So I didn't panic. I don't have enough hair to pull out, but I didn't pull my hair out. I just I kind of went back and took a look at it and realized I made a little mistake. So that kind of thing will happen to you. So just keep calm and just try to figure out what the mistake was. All right. So, 9, well, they were kind of tricky here. You see 9 is one of the answer choices, but that's what x is equal to. I'm looking for, remember what we're looking here for? We're looking for ijk. So we're looking for that whole thing. And remember, ijk is 18x plus 2. So I'm going to do ijk, and it's 18x plus 2. And then I'm going to substitute 9 right there. And then sound effects not necessary, I guess. I don't know. It's just fun picking up a number and substituting. 18 times 9. Apparently, as I've proven, I don't know how to do math. So let's use calculator. Maybe I should use the calculator for that one. 18 times 9, so I get 162. 18 times 9, 162. Yep. And then plus 2, I think I can do this one without a calculator, 164. And then so 164 would be your final answer. All right, so pause here, or otherwise we'll go ahead and move on to number 17. All right, so another kind of diagram. So we got to make sure we get this diagram set up correctly. So if I look at, and one thing you notice on that last one is just kind of some arrows to indicate where the angle was. So like TDC is this little tiny little wedge here. So I'm going to do TDC. So TDC is that angle right here. So that is 3x plus 6. And then EDC, so EDC is 65, EDC. So that means the whole angle is 65 degrees. And then EDT, so EDT, that little wedge right there, and I'll use a different color for it, is 5x plus 11. So this little slice is 5x plus 11. So again, same idea, part plus part equals the whole. You just got to figure out what's the part and what's the whole. So the two parts in this case are 5x plus 11 and 3x plus 6. And when you take those two parts and add them together, you get the whole thing, which says that it's equal to 65 degrees. So now that I've got my diagram, again, setting up the diagram is so important because now that I have that, now I just like, oh, okay, well, I just need to add that part, which is 5x plus 11, plus the other part, which is 3x plus 6. And then that's going to equal the whole thing, which is 65 degrees. So don't try to set up this equation without having labeled that diagram first. You're just more likely to make a mistake, and it's just more confusing. So let's combine some like terms. Let me see. I have some fun with my highlighter here. So my x's are like terms, and then also my constants, so just my numbers, those are like terms as well. So if I add those things together, 5 and 3 gives me 8. 11 plus 6 gives me 17. And then now I'm going to subtract 17 from both sides. 8x equals, now I'm really nervous. I'm just going to use my calculator for everything. 65 minus 17. So we get 48. And then divide both sides by 8. So we get 6. So again, you notice they're tricky. You see 6 is one of the answers, but that x is equal to 6. But what we're looking for, what are we even looking for? We're looking for TDC, right? So TDC, again, was, actually, let me use red. So TDC is this angle right here. So TDC is 3x plus 6. So angle TDC is equal to 3x plus 6. Here's the fun part. You get to pick up a number, drop it off. Whoa, right there. And then we use parentheses to do our substitution. So 18 plus 6, 24 degrees. There it is. Pause here. Or number 18. All right. Last couple questions get into area, and then we're almost done. So hang in there. This is 18, and then there's a total of 27. So we're almost there. Area. So area of a triangle. If you think about a triangle, well, think about a rectangle. I think you know that the area of a rectangle is length times width. We also like to say base times height. And then so if you think about, so if the area for a rectangle is base times height, let's go to area rectangle. It's a little picture of a rectangle, is base times height. But what about for a triangle? Because that's what that is. That's a triangle. Well, if a triangle is just half a rectangle, right? If you kind of think about it, if you cut a rectangle in half, then what you have, this shape here, is a triangle. Well, if the formula for area of a rectangle is base times height, and a triangle is just half a rectangle, then your area of a triangle is going to be base times height divided by 2, right? Because we're just doing half of it. So the base, now there's some other numbers up here, but we gotta identify which one's the base and which one's the height. So the base and height are always perpendicular to each other. So the base on this one is going to be 8, and then the height is 5.1. We never use the slanted sides to measure height. When you go to the doctor and they measure your height, you stand up nice and tall and straight. You don't stand on one leg to the side. So we never use the slanted heights or the slanted sides for the height. It's always the height is always perpendicular to its base. And then so we'll set that up, and we're going to use a calculator for this. So we'll do base, which is 8, times height, which is 5.1. And then that's going to be divided by 2. And then I'm not going to do any more from here. I'm just going to let the calculator do the work. So I'm going to do 8. So I'm going to do 8 times 5.1 divided by 2. And then I get 20.4. And area is always written as units squared. Because by definition, area is how many squares can you fit into a shape. And so we're always saying units squared. And so that would be your answer right there. Pause or move on. 19. All right, so we have our shape here is anytime you have a shape that has one pair of parallel sides, right? These sides are parallel to each other. That's a trapezoid. And so our formula for area of a trapezoid is the height times base 1 plus base 2 divided by 2. The proof, we went into the proof of this in class, but basically a trapezoid is just like a triangle is half a rectangle. If I took a parallelogram and then I cut that in half and I cut it in half like this, then now that looks like a trapezoid, right? And so this is where we then get the idea of there being, well, there's actually kind of like two bases. There's like base 1 and base 2. And this would be base 2, right? Because those match and then those match. It's just flipped. And then, of course, we said any shape, we never measure the height by the slanted side. So the height is always perpendicular to its base. So that would be the height. So this is where we get the idea of, well, if we just wanted half of that, though, because that's 2 trapezoids. So if I just wanted one of the trapezoids, then I'm going to cut this in half. And then so that's where we get the idea of whatever the height is times base 1 plus base 2, because they're different distances, one's shorter than the other, and then all divided by 2. But anyway, so that's kind of the proof of it. But so there's the formula. We'll kind of work with it. Once you have the formula, it's just kind of plug and play. So we'll kind of think of, it doesn't matter which one you want to call base 1 and base 2. So I don't know. I probably out of habit, I call the shorter one base 1, but you don't need to do that. So base 1, base 2, and then the height. So really all we're doing is just plugging in. So the height is 7.9, base 1, 2.5, plus base 2, which is 7.9. And then that's all divided by 2. Again, I'm going to use a calculator for all that. So I'm going to clear this out. So 7.9 times, and then I'll just do some parentheses here, 2.5 plus 7.9. This is just a coincidence, by the way. The fact that the height and the base are the same, that these two are the same, that's just a coincidence. There's no special meaning in that. 2.5 plus 7.9. And then we'll do divided by 2. So we get 41.08, which is that one right there. 41.08 miles. That's a really big trapezoid. Maybe it's a state. Who knows? All right. So we're getting there. So pause here, or we will move on to number 20. All right. So parallelogram. So parallelogram is, a rectangle is base times height. And then so all a parallelogram is a slanted rectangle. So, but to find the area is still the same idea, the base. Again, we don't use the slanted sides for height. So we'd have to know the distance that's perpendicular to the base. And so that would be the height. But so the formula is going to be the same, whether you're talking about a rectangle, base times height, or you're talking about a parallelogram, base times height. Right? This would be a rectangle and then parallelogram. All right. So let's set this up then. So base is 9.1. So we've got 9.1 times the height, but we don't know what the height is. I'll just call that x. And then we do know the area. It's 36.4. Okay, well, this is just kind of a simple little one-step equation. The opposite of multiplication is division. So to undo that, I would divide by 9.1. And then I'm just going to use my calculator. So we'll say 36.4 divided by 9.1. And we get 4. So what was the height? The height, we don't have to do any plugging back in or anything like that. So they were asking for the height. That's the height. So the height would be 4. All right, moving on. 21. So same type of question. We're just missing, remember, the area for a trapezoid is the height times the quantity of the base 1 plus base 2, all divided by 2. So what's missing here is the height. We know what the area is, so I'm just going to start plugging stuff into this formula. So the area is 14.6. The height is, I don't know, so I'm just going to leave that as h, or you could use x too. Base 1, which would be, and again, it doesn't matter which one you call which one, 7.7 plus 3.1, and then that's all divided by 2, right? All right. Well, so in algebra, anytime you've got a fraction and you want to get rid of that fraction, we multiply by what's called the fraction buster. So if you multiply, let's make a note here, multiply by the denominator. So we're going to multiply by the denominator to get rid of the fraction. So this is true anytime, any problem you got a fraction, you don't want a fraction, then just multiply by the denominator, whatever's on bottom, because what happens is those two things cancel each other out, and now it's not a fraction anymore. So, and of course, what we do to one side, we got to do to the other side. So let's do 14.6 times 2. So if we say 14.6 times 2, get 29.2. And then equals h times, let's go ahead and combine that. That's 7.7 plus 3.1. That would be 10.8. And see, now what I've done is that now I've gotten rid of the fraction. So now no more fraction. And then so now I can then just divide both sides by 10.8. And then so I get h equals, and let's do 29.2. So we'll do 29.2 divided by 10.8. And we get 2.7. It says 2.703, blah, blah, blah. Here they tell us just to round to the nearest tenth. So that just would be one decimal place. So we'll just cut that off at 2.7. So we'll say approximately 2.7 yards. That's the units we're working with. And so that would be your answer. All right. So let's move on to 22, or you could pause here. Number 22, this is using a diagram from the image sheet. This is diagram number 2. They tell us that AB is equal to 2x plus 6. So this part of it is 2x plus 6. And what I would do is on my scratch paper, I would draw that the segments there. I would reproduce that on my paper so that I can label this. BC is equal to 5x minus 6. And then it says B is the midpoint of AC. So B is the midpoint. So what that means is that midpoint means the halfway point. And so if we're talking about halfway point, then that means that these two things are equal to each other. And it says AC is congruent to CD. So then what that means is that this section, by saying that AC is congruent to CD, that means that these two are equal to each other. Okay, well, if we know that these two are, let's figure out what these are, and then what they're asking for is to find AD. So if we want to find AD, then what that's asking for is, that's asking for this whole distance. Well, let's start by finding the small parts here, and then we can figure out what that is, and then we figure out what that is, right? So 2x plus 6, we're going to set this equal to each other. So 2x plus 6 is equal to 5x minus 6. And then we'll solve for x. So we get 6 equals 3x minus 6. Add 6. And 12 equals 3x divided by 3. Get x equals 4. Now, don't pay any attention to that. That's not our answer yet. We got a lot. We got to fill some stuff in here. So if x is equal to 4, then I can, if I plug this back in, so like if I want to know what AB is equal to, then I just need to plug that in. So 2x plus 6, and then I'm going to plug in 4 right there. Well, that would be 2 times 4, which would be 8 plus 6, which would be 14 on top of my head. Okay, there it is. Maybe I should move myself. There we go. All right, so AB is equal to 14. So if this is 14, and then these are equal to each other, that means that those are both equal to 14. Well, if this distance is 14 and 14, that means that this total distance is 28. And then if this is 28, that means this is 28. And then if you want to know the whole thing, 28 plus 28 is going to be 56. So that means that my final answer here would be 56. But again, drawing that diagram is really important, because if you hadn't had that, it's easy. Once I got what x was equal to, it was really easy for me to figure it out from there, because I had my diagram all set up. So that's a very important part. Pause here, or we'll go ahead and move on to 23. Number 23 is going to be a similar problem to the last one. 22 was looking at segments and adding those segments together. So this is going to be similar, but instead of segments, we're going to be looking at angles. So it says, and as with all these problems, the crucial part in the beginning is taking your time to make sure you get the diagram set up correctly. So I would go ahead and write this diagram out on my scratch paper, so that I could label it. HFJ, so HFJ. So HFJ is this tiny little wedge right here. And it says that it's equal to 10x minus 7. So this part right there is going to be 10x minus 7. And then it says HFK. So HFK is this larger piece. So it says HFK, which would go from here to here. So HFK is going to be 14x plus 4. And it says that JF is an angle bisector. That means it cuts it in half. So what that means is that these two angles are congruent. So that angle is the same as that. And I can only claim, I can't claim it because I looked at it and it looked that way. The only way I can claim that is because they said it's an angle bisector for HFK. So if these two are the same, then that means that this is also 10x minus 7. And it says that angle KFH, so this angle, is congruent to GFH. So GFH would be, so what they're saying is that this angle, this whole angle, is congruent to this angle. Okay. Well, so meaning that if I know what this one is, then I could just add the two together and that gives me the whole angle. Because what we're looking for in the end is it says find the measure of, use a different color here, GFK. So in the end, the final answer is we want to know what is this whole thing, right? So we want to know what that whole angle is. So let's start by figuring out what we've got, what they gave us here. So 10x minus 7 plus 10x minus 7 is equal to 14x plus 4. So that would be, if I combine those, that's 20x. If I combine those, that's negative 14. Equals 14x plus 4. So I'm going to subtract 14x. Oof, getting messy here. Subtracting 14x minus 14x. That would be 6x minus 14 equals 4. Let's add 14 to both sides. And I'm kind of going through this part of it a little more quickly because I'm thinking that, you feel pretty good about this solving the equation part. And then x equals 3. Far from being my final answer, I first of all need to figure out what this little angle is. So like angle HFJ. So angle HFJ, HFJ, that's the one that I did in blue there. I'll switch to blue. So it's 10x minus 7. And then so I'm going to substitute in 3. So 10 times 3 would be 30. 30 minus 7 would be 23. So that means that this is 23 degrees. Well, if that's 23 degrees, that means that's 23 degrees. And then so if I want to know what those two things are together, that 23 plus 23 would be 46. So that means that the arc here that I have in red, that would be 46. Well, it said that these two are equal to each other. So if this is 46, then that means that this is 46. And then what we're looking for in the end is the whole thing. So I'd have to add these two together. So 46 plus 46, right, would give us 92. So that would be our final answer. So a similar problem is 22. 22 is the same idea, but with segments. 23 is kind of the same idea, but with angles. Pause here, or we just got a couple left. All right, so 24 and 25 are what we call composite shapes. So these next two problems deal with when you're trying to find the area of what we call a composite shape. Composite, that just means a shape that's made up of other shapes. So it's kind of like, it's not just one shape, it's kind of like a big blob of a shape that is made up of other shapes. And so how you decide to dice this up or cut this up is entirely up to you. So someone might see maybe cutting a trapezoid here and cutting it a different way. So I would say cut this up, whatever maybe makes the most sense to you. That's how maybe I'd cut it up. I'd probably cut this way just because what jumped out to me. You probably want to cut this up in as few shapes as possible, right? Because the less shapes you cut it up into, then the less work you have. So I would probably see this as I would see this as a triangle, right? So you got this triangle. And then it's a triangle that's then on top of this parallelogram, right? So then you've got this parallelogram underneath it. So if I want to find the area of the whole thing, I just need to find the area of the triangle plus the area of the parallelogram. Just feel like coloring now at this point. And then if I know the area of each individual shape, then I'm just going to add the two things together, and then that's going to give me the area of the whole thing. So they give me some numbers to label the diagram with. So let me go ahead and do that. AB is 2. So here's, I'll use a different color. So that's 2. BC is 10. So B to C, so that's this distance here. CD, this distance. EF is 4. So E to F, which in this case is 4. FH is 5. So FH is the height of the triangle. And then BG is 6. So BG would be the height of the parallelogram. Okay, so let's figure out, first of all, area of a triangle. We know the area of a triangle is base times height divided by 2. And then the other shape I'm working with here is the area of a parallelogram, which I know is base times height. So let's start with the area of the triangle. So I'm just going to do area triangle. Base, do I know the base of the triangle? Not yet. I got to figure that out. Well, if the distance across here, let's see, the whole distance across the bottom, let me kind of look at this in a different way. The whole distance across this bottom, right? Because they give me kind of in segments, but I need to know what's this whole thing across here. Well, the whole thing across is 2 plus 10, which is 12, plus another 2, which would be 14. So the whole distance across is 14. Now, it says that this part of it, this part right here, is 4. So if that part is 4, the whole thing is 14, then that means that this distance is 10, right? Because 10 plus 4 makes 14. And then so if I took, actually, let me double check that. Okay, sorry, I had to pause that for a second. Quick correction here. We're actually the 2, you notice I was adding it, I said 14 minus 4 to get 10. But this 2 here sticks out further than what that triangle does. So the distance that we're actually looking at, let me make a little correction here, is really the distance. So the tip of the triangle here, if we went straight down, so it's from B all the way over to D, right? So it's really 10 plus 2, which is 12. 12 minus 4, which would be 8. A little tricky. All right, so base is 8 times the height, which is 5. And then that's divided by 2. So we get 40 divided by 2, which would be 20. So this would be 20 inches squared. Now we just need to figure out the area of the parallelogram. So area of the parallelogram would be base. The base of the parallelogram is, as we just kind of mentioned, is 2 plus the 10. So the base is 12 times the height, which is 6. So that would be 72 inches squared. And then we want to know the total thing. So to know the total thing, then we're just going to add these two things together. So we're going to add those two together. And so the total area, 20 plus 72, would be 92 inches squared, which would be that one right there. Pause here, or we'll go on to 25 and just got a couple left here. So we have another composite shape here. Let's get everything labeled first, and then we'll figure out how to cut this one up. So OP is equal to 6. So OP, so this would be 6. And then OM is 3. So OM looks like the height of this little distance there. And then RN, so RN would be 9. And then QR would be 13. So QR is this distance here. So this would be 13. And then QJ, which would be 9. And so we kind of get what this looks like is it looks like a rectangle, right? Like let's say if I filled this in, let's say if I did this here, and if I filled that in, say I filled this in here, this, so I got a parallelogram here. But if I thought about it, it looks like once I fill that in, then it just looks like a rectangle. So I've really got kind of two things here. I've got the area of a rectangle, which area of a rectangle is base times height. And then I think if I just subtract the area of the parallelogram, right, and then that would tell me what's left over, right? So then if I did area of a parallelogram, which is also base times height. So let's figure out what the area of the whole rectangle is. So the area of the rectangle is base times height. So it'd be 9 times 13 or 13 times 9. So 13 times 9. So let's do 13 times 9. So we'll do 13. So I get 117. That's centimeters squared. And so here's my strategy. I think if I took the area of, if I do the area of the rectangle minus the area of the parallelogram, then that would give me the total area. So that's a little bit different. Like the last one, we took the two shapes, we added them together to get the total area. This one, we're taking the two shapes and we're subtracting to get the total area. So let me figure out what's the area of the parallelogram here. So the parallelogram, so the base of this thing, well, let's figure out what the base of it is. If this is 6, that means that this would be 6. So it'd be base, which is 6, times the height. They give us the height there, it's 3. And then, so 6 times 3 would give me 18. So if I want to know what the total area is, I'm going to just do the area of the rectangle, 117, minus the part that I don't want, which is the parallelogram, and then that would give me 99. 99. 26. We've got 2 left. The last 2 questions involve identifying a shape. And so it's asking about shape B. So shape B is this one. Notice that there's no right angles that are, I mean, your first thought might be that it's a rectangle, but notice that there's no right angle marks. So I'm going to say no right angles given. So if there's no right angles given, I can't say that's a rectangle. Now, if it looked like this, if the right angle, if the little boxes were there, then I could say it's a rectangle, right? And that these were parallel, but it's not. So then I can't say that. Kind of identifying like what it's not. Are all the sides, you know, a square has all sides congruent. Does this have the tick marks for showing sides congruent? It doesn't, so I can't say that it's a square. A rhombus is D, where it shows all sides congruent, and a square also has 90s. So I don't see anything about congruency marks, so I can't say that it's a rhombus. So the best I could say is that it's a parallelogram, because it at least has opposite sides parallel. It doesn't tell me anything about the angles. I don't know what these angles are equal to, and so for that reason, I can't say that it's a rectangle or a square. And because I don't know what the side lengths are, I can't say that it's a rhombus. So the best I could say is that it's a parallelogram. Now on 27, we're looking at shape D. So shape D, and I think I already kind of mentioned it, but let's say kind of what it's not. So it's not, look, I don't know anything about the angles. And so I can't say it's a rectangle because I don't know if those are 90 degrees or not, and they certainly don't look like they are. A trapezoid has one pair of parallel sides. So with a trapezoid, you have a shape where you've got one pair of parallel sides, like the top and bottom are parallel. I don't say anything, there's no parallel line marks here, so I can't say that that's a trapezoid. A kite is, you have these adjacent sides that are congruent. So you have like these sides are congruent and then these sides are congruent. But this is saying that all four sides are congruent. So if all four sides are congruent, that's our definition for a rhombus. All right, well, so that completes the review for the Unit 1 practice test. I hope this was helpful. You can go back and listen to or look at the explanation again for different problems. Fast forward. This was a long video, so fast forward through the problems that you don't need help with, and so that you get to the ones that you do. All right.